We will get all this out of here.
Hey, everybody, we'll wait a couple minutes as people join.
This is the time for my device. So smart. Those aren't done, babe. That's the only thing that's not done. And we'll put them in for longer. And we'll take out the shrimps, crabs, and the chickens. And we also have some piazza. Look at that. Your imagination. Oh, you're done? No.
All right, everybody, we'll get started now. I might have a couple of people coming in a little while. So we had the quiz on Monday. I know a couple people were had bad connections on Monday. I think I got quizzes from everybody who told me they were sending them. We had one illness, and if there's anyone else that hasn't taken the test or the quiz, please send me an email like tonight, and let's try to work out some time to get that done. I think I've graded almost all of them. I might have a couple that still, or I might have one that just came in, but I graded almost all of them. On the whole, people did pretty well. Was there any questions about the quiz or anything you guys wanted to talk about?
Pat, did you get mine?
Who's talking? Jack? Yes, I got yours. Yes.
Okay.
I got yours. So hopefully it didn't seem too difficult. I know, some of the harder stuff is the network diagrams. People did pretty much all right on that. There was the one dummy task is the one thing that kind of throws people off. And it's not a big deal, but I think when you have dummy tasks, you try to label them all similarly, so they can be easily identified as dummy tasks. The convention they use in the book is a D with a subscript or postscript, either up high or down low, something like that. On the example I had provided where you had to fill stuff in, not the example, but the question I had where you had to fill stuff in, there were 2 dummy tasks that preceded the third one, D1 and D2. That was a couple people had put another letter, probably referring to the task right before it or after it. But other than that, we had some good grades on the quiz, and I think everybody seemed like they at least had a pretty decent grasp. The other thing, I know there were 3 or 4 questions trying to identify the difference between tasks and activity and event and milestone. Just quickly, so how those are usually called out, especially in an arrow diagram, but this goes for in general as well. Task and activity are usually, they're used kind of interchangeably. And basically the difference between those and an event or a milestone means the task or an activity, something is being done, or someone's doing something, so that has a duration. So that has a set amount of time, whether that task is, it could be 15 minutes long, it could be 4 weeks long, but it has some kind of duration. There's time associated with it. A milestone is more of a milestone or event. That's more of a marker in time. So, the task could be, bricking a wall, putting up a masonry wall. That could be the task or the activity. And then the milestone could be, brick wall completion, brick wall start. Those they don't have durations. That's just a point in time. So it's, I know it's probably seems a little bit, not too big a difference between those, but technically it is. When you're doing schedules and when you're doing bar graphs and all that stuff, marking a milestone or an event, milestone by definition is an important event. So it's not an activity. You don't have a milestone that takes 2 weeks. You have a milestone when you either meet a certain goal or you meet a certain amount of work done, something like that. So that was a couple people got confused on those, I think. But other than that, I thought people did real well on this quiz. I was happy to see it. So that's. I'm just waiting to send them back. I think, I still have 1 or 2 left to grade. So I did want to get those back before I sent your grades, set your quizzes to you marked up. But I do have in the grading, I put the grades in Blackboard grading center. So hopefully you guys can, and most people can take a look on there and see where they've landed. Also keep in mind, what day is today is, so I think on the 24th, I'm going to give a couple extra credit little assignments. Those will make up, if anyone didn't feel like they got as good as they could have on the test, you're welcome to do the extra credit. That'll help you make up any score or anything you want there. So that'll be available on 2/24. And it'll just be, some extra work on something in those first 4 chapters. So the other milestone, which I don't think we've met yet, but I think we're very close to meeting it, is everybody having Primavera P6 downloaded on their computers. I think there is one person that I know of that does not have it yet. They're going to be picking up a computer from Francis in the next couple of days. But other than that, I believe, is anyone else, besides the student who's picking up a computer from Francis, is there anyone else who was unable to download Primavera P6? All right, so I'm hearing that we just have that one student left. So by, midday tomorrow, everybody should have their hands on Primavera. And, you're welcome. Like I said, it's a 30-day trial license. We are going to try to get our work done fairly quickly. And like I said, it's not a complicated, project that I'm looking for. So we shouldn't have too much trouble getting it in before the 30 days. We do want to make sure, I'm not a huge stickler on if you have to hand in something a little bit late because, we all have lives and all that kind of stuff. In a case like that, when we lose access, let's try to make sure nobody has anything, holding them up or try to do their work as soon as they can. So we don't get to day 32 and someone hasn't finished, and then we gotta figure that kind of thing out. So if you would do your best to make sure we stay on time with the project. And then the last point I was going to make was I sent out the project description, and I wanted to go over that quickly and see if there's any questions or we need any clarification. Let me quickly open it up. Project number 1. All right. Share. Do you? Application window. All right. So for project number 1, we have the due date at 3/8. That's, I know we're 9 days into that now, but like I said, it's not too big of a project, so hopefully we can get it done in the next 2.5, 3 weeks. The project, what I want to do, the point of the project is for you guys and ladies to create a schedule in P6 and just get some familiarity with the program itself, see how it's used, see all the inputs. You're welcome to also mess around with it, on non-class time. There's nothing wrong with doing that and trying to get used to it. So what we're trying to do is I want you guys and ladies to become, so in this project you're kind of acting as a scheduler, a project manager. You're kind of the whole kit and caboodle here. The owner, you guys will, I'm asking you to define a project, meaning you will pick the project where it's going to be at, what type of your house, someplace you work, a classroom, Great America, whatever, some kind of location where you're going to undertake a project to basically upgrade your facility so to minimize the risk of COVID-19 transmission. We've all, I think, probably heard a lot about COVID-19, about trying to minimize the transmission of it. The known transmission paths are in the airborne, kind of an airborne thing. That's why we wear the masks. ASHRAE, who is the American Society of Heating and Air Conditioning Engineers, something like that. They have a couple documents where they make suggestions, and this is kind of a new, obviously this is kind of a new disease, or it's not disease, the new virus that we don't have long-standing history with, but we do try to take our best guess to the steps we can take to avoid transmission. Some of the suggestions are the more being outside, the more fresh air you have within your space or your area, wherever you are, the more outside air is what we call it in heating and air conditioning. When an air handler, a furnace, sucks in a certain amount of air from outside and uses that, mixes it into the return air of a furnace or a air handler, and pushes that portion of the fresh air into the room. And there's codes requiring certain amounts. A lot of times they deal in what's called air changes. Basically, they're saying with the amount of fresh air you're taking from outside, let's say it's 200 cubic feet per minute, CFM. Imagine, or considering we had 200 CFM, my room is, X, 4,000 cubic feet. How long would it take me to suck in enough air to replace enough fresh air to replace all the air in that room a certain number of times? And I know that probably didn't sound that clear when I just said it, but basically what we refer to that as changes. How many air changes, meaning how much fresh air replaces all the return air, do you get for a facility in a set amount of time? Offices are, in Chicago at least, offices are supposed to get 2 air changes per hour. Some more like health clubs, things like that, they might have 6 air changes per hour. I know, operating rooms that I've had to design, some of them go up to 15 air changes per hour. So they're, and basically you get to the point where there's no return air. It's all fresh air from the outside, but you do have to temper that air. You have to heat it, cool it, dehumidify it, humidify it, make sure it's comfortable, and that takes energy too. So that long explanation was just for the fact of that's one of the suggestions to avoid COVID-19. More fresh air. I think I told you guys last time that my kid's school just has all the windows open all the time. That's one way to do it. There's a better way to do it, is if, at your air handler or at your furnace, suck in more air from the outside. Higher filtration. Again, operating rooms and clean rooms where they make, pharmaceuticals or something, they usually operate on what's called HEPA filters, and it's like 99.9% filtration of particulate. Sometimes you hear that word around when someone's trying to, like, I think the Dyson vacuum says something about HEPA filtration or something like that. So basically for those that real good filtration where it filters out all but the very smallest particles, you have to have a special kind of filter for that. And sometimes that filter is, I think they're either 1 or 2 foot bags, we call them, long. So it's, think if you're familiar with the filter for a regular furnace, it's about they say 1 inch thick, but it's not even. It's like a 3/4 of an inch thick with a, cardboard frame around it and some, blue meshy material inside. That level of filtration is, I think that might be MERV 2. MERV is the ratings for filtration. HEPA filter I think they go to MERV 12 or 14, something like that. A very high level of filtration for a regular commercial space would be MERV 8. You can move up to MERV 13. Actually, I'm not sure what HEPA is. It's higher than 14. But that's another possible change you could make to your building or systems. changing out light fixtures so people aren't touching them. Plumbing fixtures, same thing. Copper finishes, putting a copper countertop. Copper is a natural virus killer or something like that. It just, they can't survive touching copper. And then if there's anything else out there that you guys come across or think about, or basically an upgrade or renovation to execute a project that will reduce the transmission of COVID is the scope, is the general description. How we start that is, okay, let's define the scope. What are we doing? We are replacing our our entire furnace with a new one with more fresh air outdoor intake. Okay, that's just an example. Okay, so if I want to do that, is it just the HVAC guy? Well, our new furnace is going to have a bigger fan, so we're going to have to put in a 20 amp circuit and not the 15 amp circuit that's in there. So the electrician will need to come, and he'll need to disconnect the old furnace and reconnect the new one, maybe pull new wire because the existing wire for a 15 amp circuit was small or something like that. So I want to try to have you have the class come up with a scope and then try to think through that scope. Who's going to be doing what on the project? You know, I know some people are more less experienced in construction. This is kind of your first, you're just getting your feet wet in it, or you know, this might be your first kind of commercial construction experience, something like that. I'm not asking you guys to know everything or to, you know, feel pressured because you're not sure if you need to have a controls engineer to do this or that. Let me know if you're having trouble and you want to go over it. We can set up, you know, 15, 20 minutes or half hour, and we can talk through it and see, okay, what contractors am I going to need? How many man hours, that kind of stuff. So the first deliverable will be the scope, describe the project, the listing of the tasks, and I can help out if you want help listing the tasks and what contractor would be responsible for each task. Deliverable 2, for each task, identify the duration and provide basis for your estimate of the duration. Identify the critical path, early start and early finish dates for the tasks. So that's where you can start, you know, once you have a pretty good idea in your head what the tasks are, you can start working on in Primavera. And I don't know how many people have gone into Primavera yet. We'll do a little more hands-on example of it on Monday, just so, you know, when everybody has their hands on Primavera, we'll go through maybe putting a couple things in to see how it works. It's not, there's a lot of information in Primavera, and it has a ton of capabilities, and you know, like most things, that tends to make it a little more complex and less intuitive to use. Feel free to mess around, do one for your bathroom, refinishing your or rehabbing your bathroom or something like that. You're welcome to mess around with it just to get, you know, familiar with what it looks like, where the inputs, you know, how long or at what point you put in what inputs. You know, a bar graph that we look at, you know, some of them will have a line for units or work hours or, you know, rate, something like that. We don't necessarily think of that when we talk about schedule, but those parameters are a very big part of it. And I know chapter 6 we go into some of that, like the leveling, the resource leveling, things like that. But it's an important topic in scheduling, so it'll be good for you. They also have a lot of tasks in there broken up by kind of a typical project or a typical electrical project or a typical, you know, it gets more detailed. So you may, you know, messing around with it, you might see some tasks in there for, you know, replacing a plumbing fixture that you might not have thought of. a drywall person has to come in here and cut out the drywall so we can access the piping, something like that. So, and then the final deliverable for the project will be, a schedule created in Primavera, sent to me in Adobe format or something, showing all the tasks, who's responsible, the person in charge, PIC, pick, we call that sometimes, the critical path, early start, finish dates, and that's, putting that into the schedule, just getting used to using it will be helpful for everybody. So does anyone have any questions on the 38324? Yeah.
Yeah, I have a question.
Yeah.
We have the last deliverable as to 324.
Yep, I just saw that myself, and when I was looking down, obviously we're not going to have that kind of time. Did anyone? So everybody, did you guys download like last week? I think maybe.
I just did it today, this afternoon.
Oh, okay, good. So I'm going to have to kind of push that up a bit. February. So, the 3.1 I'm still okay with. That supposed to be deliverable 1, 2, and 3. But yeah, we'll have to condense that a little bit because we have kind of lost a week trying to get this in place. Some people, Susan, you'll be good then until 3/17 at least. But I think some people at least got it on the 15th or earlier. So I'm going to probably use the 15th as our date to try to get our final product in for. I'm going to for the homeworks for the next 3 weeks, I would highly suggest you do them. But I know you're going to have this project, so I don't want to be overloading people with things from this class. So I'll send out an email revising the homeworks. I would still recommend you do them. The problems we pick are picked because I found them useful and good representatives of that chapter, representation of what the important topics are. You don't have to turn them in. You can do them at your own pace. And you feel free to ask questions if you do have trouble with them. But like I said, I don't want to overload anybody with the Primavera and the homework at the same time, especially the condensed schedule. So I'll send out a new schedule, Susan, and people can pipe up if they don't think it's going to work for their schedule. But we're going to go for probably 3/15 for the due date, or possibly, maybe a little bit before that, but 3/15 would work for most people, I believe. So, any other questions on the project?
You know what, Pat? I was just looking over at Primavera, and maybe some of the controls or buttons at the bottom allow for like budget and calculations and all that stuff. We really don't have to get like deep into it. Or is that a suggestion that we could kind of skate over?
So when we do the schedule, I am going to ask for, if your project has replacement of all the light switches in a school, say, okay, so we have 40 light switches and we got to replace them. I am going to, one of the requirements up top or parameters that we want to add to the schedule is kind of man hours or some form of measurements of total, work hours, how long it takes, basically. So, that's always something you want to, any task when you're trying to identify the task and quantify it, you want to make sure that you're not, telling people to do 40 hours of work in 8 hours, something like that. So that is one of the parts of the schedule tasks and line items that you'll fill in. Now, I know what you're talking about too. There's like, there's, like I said, there's a ton of information in Primavera. Ours is going to be pretty simple, and we'll go on Monday. For the next 3 weeks, we'll spend about 20 minutes together in class, kind of going through the examples and tasks of that, how we input them, what we use as a basis for those kind of things. So you're not going to put everything in, obviously. I'm not too concerned with budget right now or anything like that. This is strictly scheduling for Primavera, so it shouldn't get too complicated for you. And just for clarification, chapter 6, I believe, is the resource allocation chapter, and that is a big part of scheduling. So, and I'm just going from my experience. So if someone has something different, feel free to interject or tell me I'm wrong. But usually outfits that have someone who's dedicated to scheduling, they will use that scheduling to do what they call resource allocation. And basically it's just trying to forecast, what work you have coming up, how many hours you have to do that work, and does your workforce, or how many hours are needed to do that work, and can your labor force cover all those hours? It's just, resource allocation is a fancy way of saying, forecasting labor. And, we had schedulers at ComEd, and the one thing is they did use those, especially ComEd had, they had some in-house electricians. They also had a lot of contractor electricians, so they wouldn't do, they probably did maybe 10 or 20% of the actual construction work for our capital projects. And the thing was, if you wanted to use in-house labor, you had to tell them quite a bit earlier, like at least 4 to 6 months before the project was to start. You would have to go to the different regions. They controlled the labor at each of the regions, and you'd have to say, hey, here's my project. The estimate has this many man hours in the project. We're trying to finish it in this amount of time. Is ComEd's in-house labor force interested in doing that? And so they go through, kind of a vetting process, make sure they understood everything. And then they would take that. So if they didn't accept your project, they would take that and put it into their schedule, which was, 4 or 6 months out. And, because they had to try to make sure to keep their labor force working. They didn't want to give it all to contractors, and then they have a bunch of free time for their people that could be, doing something better and, installing capital projects, stuff that was worthwhile. So that's kind of the resource allocation part of it. Basically, we're not just a project in most cases. You don't operate in a vacuum. You have to, predict, forecasting is a big thing in construction, whether it's cash flow, labor, profitability, maintenance on your tools and whatnot. Trying to levelize, meaning I don't have a huge amount of work in March, and then I don't have enough work in April. It's resource leveling. It is a pretty fair concept in a lot of places. Like I said, especially if they have in-house labor, especially unions. So that, you won't have to put that on the schedule per se, meaning, you don't have to predict, work hours for this week for your project, that kind of thing. But you do for individual tasks. We're going to want a total amount of labor and resources required. Any other questions on the schedule on the project 1? So I will send that out tomorrow morning. I'll have that changed, Susan, with the revised dates.
Just to confirm, I don't have access to this document, right?
Oh, well, I'm sorry, I didn't hear you.
Just to confirm, we're gonna have access to this document, correct?
Which document?
The
One,
one
see
you
on my,
emailed up.
did I not send it out?
I can't find it unless you emailed it to me.
Goodness, maybe I didn't.
Yeah, I've gotten it.
I've gotten it. I don't remember
You guys
how.
find it?
Now let me just check, because, I'm sorry, someone talk again. Who didn't get it?
Emmett doesn't
I
have
think it was
so
emailed. I'm not sure though.
check that.
Emmett, I will double, yeah, right. Yeah, if you don't have it, and I would assume I put this on Blackboard, but not positive. I will put it on Blackboard regardless. Okay. All right. Anything else in terms of the project? Quiz we kind of already talked about. Anything else? I am, project 2 is, that's still being formed, but I am, just to let you guys know ahead of time, I've been trying to reach out to some of the bigger construction companies where, I might have an acquaintance or whatnot, to try to get information from their groups on, what kind of skills, what kind of, software, or what kind of, I don't know, assets can a student bring in when, so say everybody gets through this class and then they get through their course, their courses at Triton, and you go into interview at Walsh, what would it be in terms of at least scheduling that would be important to them? Be it, I know they're not going to say network diagrams or anything. I think one of them might be the BIM one, which I'm kind of talking to people about too, but I'm just trying to, I know looking at that textbook, there's lots of really, really dry academic sounding things that may or may not be very important to an employer. And I'm trying to identify, if you can walk in with a couple P6 schedules that you did or something like that, I'm trying to identify things like that'll mean something to the people that are hiring. And I'm not that we don't all love education for the sake of education, but we do, if there's something we can work on during this class that can make you more marketable, I'd like to try to find out. So I talked to Pepper, I talked to Walsh and a couple other places. So I'm trying to put together some little document to see what the second project will be. All right. I think that's,
Yeah.
yeah.
I have a question on the homework. So
Sure.
for the exercises for chapter 4, I think,
Yeah.
I can't tell what's due when, because 5 was before 4 at one point.
I had the syllabus up.
No, I was looking on Blackboard, so maybe I should have been looking at the syllabus.
I will. So okay. Now I remember. I did put 4 and 5 up on Blackboard at the same time. I think
Okay.
that might be where the confusion came from. So up through 5, which is last week. And I know we had. I probably confused you with some of that stuff. The homework 5 will be the last homework due for the last during this project. So if you get homework 5 in, and assuming 4 is in as well, homeworks 4 and 5 in by the end of this week, or how about maybe by end of next Monday, that'll be fine for everybody. If that's acceptable, do you think, or
I think
was there something specific?
that's okay, Pat. With me, anyhow. Okay, thank you.
Okay, yeah. And I'll try to clarify that on Blackboard. Maybe it was less than clear too. So homework 4 and 5 will have those due at the end of the day and Monday next week. Monday. Okay, anything else? So we did, last week, I think we got into chapter 5 on the, I'll bring up the presentation. Chapter 5, we did not get through chapter 5. There were a couple points I wanted to just run back and highlight because they are important. So I'm going to pull up the chapter 5 presentation quickly and go through the second half of it in about 10 minutes just to kind of point out the important things. Chapter 4 was the critical path. I feel like, you know, there's a critical path is obviously the big deal in scheduling. Always trying to identify what the critical path is, how to show it, how to work around it in the most efficient way, and oftentimes how do I shorten it. That's pretty much what I usually see in terms of, let me share differently. One second. All right. 1 second, please. There we go. Share information screen. All right, so chapter 5, I know we kind of started getting into all the finish, start, finish, all those kind of, all that terminology. I know some of it seems kind of confusing for confusing sake, the way we have all the FF, SS, trying to remember all those things. The couple things that we do want to make sure we keep in our mind, we talked about that the float is an important calculation in what we're talking about. Free float, obviously, or free float was free float was in our project when you have you have your critical path identified. Some of the tasks are not going to be part of that critical path. How those tasks relate. Certain things can happen during the project where something pops up differently than you thought it was going to be. You end up, somebody takes longer to do one activity, it pushes out another activity. That float, we call it free float. We may think, yeah, I got plenty of time to do that. We'll put that, near the end because I got to wait and get, my floor poured right now or this or that. So that float often gets eaten up, that where all of a sudden something that you weren't that concerned with becomes the critical path. Very common, and it becomes a fire drill at the end or towards the end side of it, at the end of the project, where you were hoping to have a nice the punch list and have the architect walk through and point out scuffs on the wall and stuff like that, and all of a sudden the mechanical contractor forgot to buy VAB boxes with coils, so that order took 4 more weeks than it was supposed to, and now what he's done with his work, but he pushed the electricians and the carpenters back because they couldn't close up the ceilings until he had his work done above the ceilings. Those are the kind of things that when you're going through your project, you know, it can seem completely unrelated. Like, how's my tile care about the you know, VAV boxes? You know, it's amazing how those things can work out, because they're just like I talked about, that domino effect of this happens, this, that, and all of a sudden, you know, you can't put the tile down because the humidity is so bad, because it's still drawing in, you know, outside fresh air, no dehumidification, blah blah blah. So, you know, the float is something that we have to be pretty careful with, tracking wise, and trying to make sure we keep the schedule, you know, I don't want to say pushed as hard as we can, because that's what tends to lead to mistakes and hard feelings during construction, when the people are pushed and they feel like it's an arbitrary decision by someone else. Well, it might not be so arbitrary. It might not be just because they want to get everything done early. There can be other relationships that as a carpenter you may not see, because, you know, you don't think too much about control wiring, or, you know, something like that. And so the free floats, restricted float, that will start restricted and restricted. Basically, it is a portion that you know, you can't do it anytime during the job, and there's a pretty set either lag, lead, a restriction that's keeping that float in a certain time frame, and whether or not, you know, something else, you know, when you go to try to shorten the duration, you're trying to expedite the project. In those cases, that float becomes very valuable in terms of trying to provide extra time for somebody else at the end. So, and not that, you know, free float matters so much, or restricted float matters so much in putting together the actual schedule, but protecting it, and just for us knowing what they mean, knowing how to identify, you know, what kind of float is where, is kind of the point of chapter 5. And you know, there's some, you know, the big thing is I want you to understand, just, you know, kind of conceptually, when we say float, free float, the finish restricted float, being able to show where that is on a schedule that we create. You know, obviously it's the end, if it's finish restricted, those kind of things. So one of the things we also talked about, the combination relationships. You know, when you have different relationships between finish, start, taking it's not continuous. Those tend to make it more complicated, where, you know, conceptually, critical path seems like a fairly easy. It's easy enough to in our heads to calculate the critical path. It's the shortest, the very shortest time frame, where we can't move anything forward, or we can't adjust the sequence of activities. It's the longest line, basically. It's the longest bars in the bar graph. When we start getting into those combination relationships, where, you know, non-continuous, different start-finish relationships, you know, that's when we'll complicate it. But that's also the opportunities. Those kind of relationships are also opportunities. It sounds like they're just complicating it, but they're opportunities to try to shorten your time. We talked a little bit, and I think one of the examples I kept using last week or the week before was putting the pipe in the ground. That can be, you know, a combination relationship, where it's not just, you know, task 1 end, task 2 start, and, you know, it's not just a linear ladder type of situation. You can adjust portions of it by working in a different area, working different work hours for, you know, certain crews or certain trades. those are the kind of opportunities. Identifying them as opportunity is important in terms of, you know, understanding your schedule, understand what, you know, can be continuous or what can't, you know, why something cannot be continuous. It's not a good idea to have the plumbers working over there, you know, while, you know, shifting over here so the electricians can work there. Those are the kind of relationships where, you know, experience comes in handy. But barring, you know, having the experience, you go to the subject matter expert. You go to the people in charge of those tasks to find out whether there is opportunities. Something like breaking up a task, making it non-continuous, and even, you know, depending on, you're going to start with a schedule, and it's going to have certain relationships and restrictions. It's not impossible, you know, something that may seem that, you know, I put out my schedule, I say this is the critical path. Just because I say that doesn't make it so. And sometimes people will tell you something because it's the easiest answer, and it sure is the easiest for them not to feel the push of somebody else doing that. You should be able to go to your contractors, to your subcontractors, to your project managers, and, you know, or maybe you are the project manager for the subcontractor, you know, identifying but not putting in jeopardy, you know, the work you said you would do. You know, we all come into these projects and, you know, we got drawings, we bid our pricing off those drawings. We didn't expect, you know, off-hour work on during the week where I have to bring in a crew from 11 to 4 or something like that. You know, we have to protect ourselves and our companies and our stakeholders in terms of, because you are going to get that push to make it a complex situation. The site superintendent has to make up, you know, 6 days because it rained and he couldn't get deliveries. So now he's going to come to his subcontractor and say, hey, all right, everybody sit down right now. We got to cut 8 days out of this because he needs 6. He's going to tell you 8. And all of a sudden they're going to be looking at every single point of your, you know, you might have provided your look ahead schedule for your trade. And they're now going to be looking at every single point on there and asking question, why not, why can't you? And, you know, that's the importance of that, is to, you know, don't make the decisions unless you are the subject matter expert, or you're in charge of running that job, or the labor or something like that. You know, you'll get pushed by people. We all have different motivations and drivers and situations. You know, construction is that's what it is. It's a big conglomeration of relationships and interactions.
Hi, Pat.
And
Could you explain the difference between the same slide, the difference between the continuous and the interruptible? The two examples.
Sure. Yeah. 410, 8.3, 610. So the difference here, and that text isn't helping. The difference here is contiguous, interruptible. Yeah, top is interruptible. Sorry, I couldn't read too clearly. So contiguous is you're getting all your work done at the same time, and you have these. We have, and darn it, I should put that slide up. Is it in this deck? What each one of those stands for is the early start, early finish, interruptible, yeah. Early start, early finish, and, you know, how you define that diagrammatically. 0 to 12, 0 to 10. And there was a good example, and I'm not interruptible, unrestricted, non-critical. Yeah. they break their critical and non-critical portions of tasks up. And it's a good question right now, and I can't answer it off the top of my head. I will write that out. I mean, my problem right now is I don't have in front of me all of the definition of the different diagrams. I'll show that to you. I'll send that over to you because I know I was doing these diagrams this weekend, and there was a very good example of the interruptible and non-interruptible, and I don't have it here in front of me. So I will send that to you, or I'll probably talk about it maybe in a quick one next week. Yeah, they don't have it here, and that's the difficulty with these network diagrams, and part of the reason I don't like them too much is even in the books, in the textbook, there's not a really great there's not really great descriptions of how you make your decisions and the processes. I spent a lot of time this weekend going through different diagrams, and I was trying to, I talked last week about saying how I did each thought, and it sure really was difficult to, clearly lay out. And it was kind of a trial and error situation. In most cases, you're just moving days around, moving parts around. And I was even looking in the books for them to give us some kind of, easily readable explanation. And it's like a logic diagram, and logic diagrams are notoriously hard to explain clearly, at least for me. But the interruptible versus contiguous, these diagrams have a very specific way of doing them, and I'll send you that. I apologize for not having that queued up. I was kind of focusing on chapter 6 today, and I didn't go through all this, so I will send that over. And like, what we were talking about on the interruptible versus contiguous, the software does also allow. So when you use Primavera P6, how do you show these interruptible versus contiguous on on a bar graph? A lot of times, breaking the actual task up is going to be easier than trying to show it as a single task and it's interruptible. Putting down a terrazzo floor, instead of making it a 2-week task, you can break it down either geographically or we're going to do all the layout this week, and then next we'll wait a week. So it's a breaking out the tasks rather than making them an interrupted task is usually going to be the clearest method, honestly, in most cases for us to go through that. And I'll send that out, and I think it would be helpful. I'll do these I did 2 of these too, and showing the actual steps on these will help my explanation, because it's again, logic diagrams are not the cleanest, easiest things to do, and without a little preparation, I'm not going to do it well. So let's take a 5-minute break, and then I want to get over to chapter 6, and we can start going through that. All right.
Okay.
We will start back up at 8:05.
Great.
Thanks. All right, I'm back. I'm gonna move on to chapter 6. That the interruptible thing, the reason I'm not getting too deeply into that diagramming is because you would use those kind of techniques during, the very kind of baseline theoretical timing of a schedule. In most cases, how it's handled, and I believe P6 doesn't even allow interruptible activities anymore. They kind of, it just complicated things, and they've chosen to kind of go into the more detailed breakdown way of doing it. So instead of having one task that's interruptible, they'll have 2 separate tasks, and the relationships, fall through them that way. In diagramming, it's definitely something that the textbook definitely covers it, and we do want to understand it. But I'm not going to be on a test. I'm never going to say, I want you to know what I want you to know what interruptible means and what contiguous means, but I will get the example for that, just so we can, understand it. Like I said, these books are a little more academic, but to me, it's kind of knowing the theory behind what you're doing, and at least grasping the concepts more than trying to diagram a baseline project or a baseline schedule for a project in those cases. So going on to chapter 6. Chapter 6 is the start. I talked a little bit about it, of the resource leveling. And, for all the reasons I talked about, a company is not just one entity working on, everybody at that company is working on the same project. A GC, the bigger ones could have 100 projects going at one time. And in those kind of cases, the resource leveling and, controls like budget, all those kind of things, those are all done to, make sure the workforce is kept productive. Construction, and it's almost a handicap, but on any construction project, we're always thinking, or whether you're a contractor, subcontractor, time is always money on a project. And if you are, having, real busy times and real, slow times, that's a problem with your resource leveling. Your management is not, properly forecasting, and, resource leveling. There's certain tools we can use for resource leveling, trying to make sure that keep the work constant. That's the goal, is to keep the work constant. There are times when you have to expedite a project, and that might might require some overtime, something like that. But in practice, the goal is always to try to keep the workflow as level as possible. There's sometimes you can't do that. It's just impossible on certain projects, certain programs, whatever it is. They might have some parameters. We can only do it during the heating season, or we can only do the work when the chillers are shut off, or we can only do the work during this ComEd shutdown because they're going to be redoing some stuff on their end of the line, and so we're going to do our factory work at this end of the line. I remember there was certain work we would do at ComEd where this was, I think, there's a Ford plant around Hegwish area, and they would shut down basically twice a year. They would shut the whole plant down. So any upgrades that you had to do had to be done during those 7 days, whatever there was. Usually, I think one of the winter shutdown was, end of Christmas through New Year's. Well, if we were doing work for ComEd and we made them take the line down for any amount of time, it was like 1.3 million per day in lost revenue. Obviously, that nobody's looking to take responsibility for that. So, you might have to, really hit a project hard, throw, multiple crews on it, have them work long hours. One of the most basic tactics in resource leveling is just working 10-hour days as opposed to 8-hour days, or sometimes it's 6 10s, sometimes it's 5 10s. But if we have an expedited situation, you do what you have to do. But in standard practice, we're always trying to avoid those kind of situations. It costs more money. Safety is always an issue when you're working longer hours and nighttime shifts, all that kind of thing. So, there are risks that are worth taking and there are risks that are not worth taking. And you want to make every effort you can to try to, put your people in the best position possible so as not to have to sacrifice, safety or, mental health. You work 6 or 7 12s for 2 or 3 weeks, you start burning out and you're getting less done. It happens in every scenario where if you had 8 hours of focused work that you could really concentrate on something, you might get twice as much as you would get done in a 12-hour shift. Or one of the other, productivity is also another big part of resource management. How the rate at which your labor can install or whatever you're doing, install, build, whatever we're talking about, it's productivity. We act like it's a constant. It's not. It can shift up and down based on job site conditions, work hours. Lots of different factors can affect productivity, and it's kind of a general. It's generally accepted where, we're talking about interruptible versus contiguous. Well, there's a thing in construction called mobilization, and that just means kind of the startup of a project or a task. We have to replace all these VFDs. We can figure out what the rate of installation is. Yeah, it takes us 32 man hours to demo the old VFD, bring in the new one, set it, and then commission it, get it up to speed, make sure it's working correctly, and it's communicating correctly with the control system, and it's operating how it was designed. That mobilization might include, bring in your toolbox or the big neck boxes to site, making sure you have the right equipment on site, whether it be it could be a front end loader, it could be a bobcat, it could be a drill. That's all effort. And mobilization, generally accepted 10%, might be what you charge for mobilization. Shop drawings, the whole submittal process, people will put that in the mobilization because you can't order equipment components or equipment until you have approved submittals and all that kind of stuff. So starting up and stopping, we're not making widgets here. We're not in a infinitely divisible task where I can just throw in hours here or there and they're all of the same productivity. So it's definitely we have to make sure we understand what the real world is, and sometimes mobilization isn't a big factor. If you're coming in and just all you require is hand tools and this or that, maybe mobilization isn't 10%. Maybe it's effectively closer to 0. We have to understand what the work that's being done, how mobilization might affect it, and what inefficiencies are going to develop if we start breaking up a task or letting, you know, if you provide a price on a project and you're assuming, you know, normal job site conditions, I can walk in there with, you know, my 4-man crew and get right to work. You know, that's rarely the case. You might have to go in and get everybody badged because they're in a high security area, and you know, you don't really do too much breakdown like that on an estimate, but you're still paying your people for, you know, the hours they're there. So making sure you don't have non-productive hours is one of the, you know, most important parts of a superintendent's job or project manager, making sure that they do everything they can. You know, the project manager, the project engineer, the executive in charge of the client, whatever they are, everybody there is for no other reason but to support the work being done. They don't often treat us that way, or, you know, it's not always the indication you feel from certain parties, but that's what the whether you call it front office, back office, paperwork, bureaucratic parts, whatever it's called, that their job is strictly to support the labor and make the labor as efficient as it can be, where you don't have people standing around because we don't have the right, you know, ductwork fitting on site. So I got to wait for somebody to drive 3 hours to bring it up here. Those kind of things, it can be killer on a project. You know, if you're not productive, if you're not working in an efficient way, you know, it's real hard to make money in an industry. And it's, you know, there's not, you know, I'll say it's not across the board, but the margin in construction can often be very, very slim. And, you know, 5% could be the overhead and profit could be 5%, could be 10%. That gets harder and harder with, you know, more competitive jobs, competitively bid public jobs, those kind of things. And, you know, we tend to think as estimators or schedulers or project managers, we tend to think, well, yeah, I'm going to go in there, I'm going to do this, I'm going to do that, I'm going to do this, and in and out. That's why one of the best resources you can have for any project is data from a similar project that your company worked on. And you're not always going to have exactly comparable situations, but you'll see, okay, well, I had 4,200 pounds of ductwork that I had to hang. How long did it take there? Because I have another 4,000 pounds of ductwork I have to hang in here. How long is it going to take? What did it take me last time? That's always the best information you can have, because you know, you get the means and the estimating software, all those kind of estimating software will usually have productivity and, you know, task duration, those kind of things. They can often be very different, very, very different, and it can cost a lot of money. You know, working in a Walmart is a lot different than working in a surgery, and, you know, things you would have to do in the hospital, you know, it's oftentimes every time you are working in a hospital and you walk into the construction site, they'll have a zippered barrier at the construction site entrance, and they will have a pressurization meter there too to make sure they're not blowing infection control measures are not blowing, you know, dirty air or construction site debris out into these, you know, cleaner critical areas. So, you know, all those kind of things you have to take into account, and how you do that can be, you know, there's lots of ways to skin a cat in that situation, and the best ways are specific examples that your company has of doing a similar project in a similar location. Resources. So when we're talking about levelization of resources, what are we talking about? People, you know, that's kind of the big driver. a lot of construction projects, labor, nearly half or sometimes over half the cost of the job. And, that's usually where you make it or break it. Sometimes you can save a little money by buying, some less expensive materials or this or that. It's all for naught when you're assuming that you had 1,500 man hours of work there and you take 2,200. Do the math there, but charging out a union journeyman in any trade almost, you're darn close to $100 an hour all in between the wages plus the benefits, insurance, all that kind of stuff. Every hour your plumber is on site, you need to be making pretty close to $100 to break even, not even profit, just to break even on that labor. So it's very important to, really, and that's also where the biggest opportunities lie. I might not be able to convince Train to sell me a cheaper air handler, but if I can work faster, if I can bring my best crew in instead of my middling crew, those are the kind of opportunities to make decent chunks of money in construction, because like I said, labor is such a big component of the costs of any contractor. General contractors, sometimes a lot of them have gotten away from even maintaining in-house labor, before, where they might have had carpenters on staff or concrete guys, carpenters, or some of those places got rid of that completely, and they subcontract out everything for that reason alone. How hard it is to manage, maintain, and make sure your labor is efficiently used, because labor is, like I said, it's very expensive, and God willing, we could all make as much as a union construction worker, but it's they're selling time in essence. We think it's expertise. In almost any case, it's time you're selling. And if you're taking too much of it, how much you get per hour is just going down, down, down. Materials and equipment. Again, these are general numbers, but materials and equipment, it depends on the project. Again, it's usually close to, usually you're trying if you get a breakdown, they'll say, 40% material, 60% labor. If you're installing a big, expensive piece of equipment, that gets totally turned around. But in general, 30-40% is on labor, or is on materials and equipment. That's why you have procurement specialists at a lot of contractors, because there's lots of different products out there, and finding the most inexpensive, whether it's a fitting or whether it's a supply house that gives you so much of a break. Those are small ways to try to recapture some of it, but you're never gonna, cut your material number in half or anything like that. Or even 20% would be very unlikely. So labor, again, is a good place to try to, your efficiency, how you communicate can really help. BIM coordination, that's what you're doing. You're doing a bunch of upfront planning to reduce the field labor on the back end. And then equipment, that's the third resource that we consider. Equipment, when we say materials, it could be air handlers, it could be refrigerators, it could be components that go into the building and stay there, capital equipment. But when we're talking about equipment for a construction company, we're talking about, excavators and front end loaders and, bobcats, that kind of stuff. That's usually a much smaller portion of the resources in terms of value, but it's still definitely considerable. Some places buy very little of their own equipment anymore. They'll rent it, or long-term rental or short-term rental, because if that's similar to labor, in terms of if you have an excavating machine that costs $140,000 and it's sitting idle for 2/3 of the year, that liability is not paying for itself in that situation. Categories: direct expense. And direct expenses, you're paying directly for the labor of a person. So your payroll is a direct expense. Materials, you buy those per project usually. Equipment, direct, assuming it's fixtures, FF&E, something like that equipment. That can be a direct expense. Subcontractors, people, if you're a HVAC contractor and you're putting in a new air handler and new VAV boxes, you may not do the control wiring. And usually a lot of construction companies, they don't have low voltage electricians on staff. An HVAC company is going to have sheet metal people and pipe fitters. They won't have a licensed union control wiring labor on their staff, so they'll subcontract that work out. Might be to the electrician that's doing the work on the job. It might be to a totally separate company. It could be to Johnson Siemens, something like that. But that cost is a direct cost. It's directly attributable to that job. I'm paying this contractor to install the control wiring on this job. That's a direct expense. Indirect expenses are kind of like the overhead, the non-specific costs that are associated with running any business, but are not directly attributable to a single project. Office overhead, the construction administration people that are sending out all the submittals and tracking all the RFIs. They may be able to put some of their time as a direct expense, but some of it is going to be overhead. They're setting up the filing system or something like that. Insurance and bonds, again, well, bonds sometimes can be project specific, but in general, insurance and bonds, that means insurance for your company, not necessarily insurance you usually don't have for project, definitely, unless you have some general liability policy that they specifically ask for, or sometimes an owner can ask for a certain amount in bonds, like a surety bond. So if that's in that case, a bond means so I'm hired by Pepper Construction to do the plumbing in the hospital. Well, my project or my company goes out of business and now Pepper's stuck holding the bag. If they had asked for a surety bond from me before I started the job, they could then go to this bond issuer and say, that was supposed to do, $600,000 worth of plumbing for me. He flaked out and now I'm going to have all these extra costs. But I asked him to have a surety bond for this project, and it was 2 or 3% of the cost, and now they can recoup some of that money, lost because of the whatever reason, contractor fails, weather event, something like that. Anything that could be, considered an insurance, whether specific or non-specific for a job. Contingency. That's a word you hear a lot in construction. I'm not sure how many people would know that term. Probably you guys are pretty sharp class, but a contingency is we only know what we know, and we don't know what we don't know. I don't know, I gave you a price to take out these 3 walls and, make this one larger space. I didn't have good drawings of the building, so I didn't know that there was a 6-inch pipe shaft in between these walls, and I now have to reroute that 6-inch pipe shaft. There's no way I could have known that beforehand. The conditions were hidden from me, hidden from inspection, hidden from view. So that would be something you use for contingency. It's to take care of the things, the unforeseen conditions that jump up on any project. depending on the phase you're in or the quality of the drawings, contingencies can be as high as 15%, depending on, you know, if there's some really big unknowns on a project. And then you get down, some companies will try to keep it around 3% of total cost. And again, what type of project it is, what method it's being contracted out in, all that matters. 5% is typical in some places, 3% is typical in others. It's not, I don't want to say a slush fund, but it is there to cover the unknowns that are on every project. There's very few projects that you don't run into something unavoidably hidden from you. That is also a place that contingency, unforeseen conditions, things like that are also a big point of disagreement on projects where, you know, an architect or an engineer will put, you know, some really broad, you know, CYA note on there that says, you know, these drawings are only diagrammatic, contractor to verify all conditions in field. Well, how's a contractor supposed to go in and break into a wall during the 2-week bidding period of where you're only allowed access to the space for 2 hours, you know, with all the other bidders? So, you know, you do see a lot of that where some owner or architect will try to argue, yeah, well, look at that general note I had on there that says, make sure this will work before you know, include a fully functioning system in your bid. Well, you know, if there's legitimately things that couldn't be known, or maybe the drawings were wrong or something like that, no drawings are perfect. So that contingency, sometimes there might be extra stipulations on who can assign. It's always the owner who can approve the changes or the use of contingency, but sometimes they'll define when and when it can't be used. Inflation and escalation. A lot of projects are, you know, 3 years long. I've had 5-year projects. You know, in current days, it doesn't happen to change too much, where inflation isn't such a big deal. But there were times, you know, in my lifetime when, you know, 12% inflation in a year. That, you know, so if it takes you 5 years to do a job and there's, you know, double-digit inflation for a couple of those years, the amount you're getting paid is much less than what it was when you started. So sometimes those will be extra line items if you know it's a very long project. The profit is an indirect expense. Like I said, 2 to 3% is what contractors will say they're shooting for. That's another thing about construction. You know, it's very hard to verify some of those costs. Oftentimes they'll want better than 2 to 3% unless they're getting a big volume of work or something like that. I've worked at a contractor who was legit making around 30% on projects, and it was because he was their contractor of choice for a bunch of hospitals. They trusted him. He wasn't going to rip him off, and we knew what we were doing. But that's definitely not the norm in construction. Usually it's a much tighter, I'd say 5 to 3%. 2% would be pretty tight unless it's a giant project. Labor, you know, you have a lot of different types of labor on a project, whether it's, you know, union people, whether it is non-union tradespeople. You have managerial, and then you had exempt employees, individual contributors, all that kind of stuff. It's just trying to define who you have that's working on a project, if they're directly cost, they can be applied directly to a project. Labor productivity, I talked a little bit about that. How much I can put up 20 feet of pipe in an hour, and so if I work for 8 hours, I'm going to get 160 feet of pipe up. You know, that can change. That can be affected by the, you know, by the site conditions, by the limitations on work hours. All those things can affect productivity. crew sizes, overtime effect and productivity and cost. The one thing about overtime that is kind of nice actually when you're working on a project is you don't usually have to pay. So if I am running a project and I tell my my electrician I need to get this done this weekend, I can't wait. We're getting our inspection on Monday. I can't wait for you guys to finish next Wednesday. Come in Friday, Saturday, or come in Saturday and Sunday with a couple crews. You'll get paid time and a half and double time, or whatever they're paying extra for that time. You don't have to pay the fringe benefits on overtime. You pay all fringe benefits are based on 40-hour weeks. So, so for a union sheet metal guy, and I was paying $53 an hour for that person, really, well, the customer is going to pay at least $100 an hour for that person. The difference in hourly, so if it's $100 an hour for regular hourly wage plus fringe benefits and whatnot, and then indirect costs for that electrician, to pay time and a half, it only goes up, by $25-$30. It doesn't go up to $150. It goes up to like $125, something like that, because I don't have to pay insurance benefits on every hour, every labor or overtime hour. I don't have to pay retirement benefits, all that kind of stuff. It's just one small benefit to doing overtime. The problem is the overtime productive? And that's where that overtime effect kind of starts to hurt you, where people know that they're going to be working 10 hours. They work slower over those 10 hours than they would have if they were working in 8 hours. So it's a balancing act, trying to get the most out of your labor resources while not extending their time and making them less productive. Crew sizes, that having the right size crew. Obviously, we've all driven by some construction project, and it looked like there was one guy working and 5 guys standing around them. Sometimes that's necessary. A lot of times it's because they have too big a crew. They didn't need 8 guys there. They should have had 3 guys or four people. The productivity calculation, whether it's in different units, basically to figure that. Man hours is a pretty typical measure of units in construction. It can be work weeks, it could be days, work days. There's a couple different ways. It depends on how you're breaking it up and what kind of tasks you're assigning. And then that is one estimators, when they're estimating, a lot of the software, like I said, will have estimating software and Primavera. They'll have, some kind of productivity measurements in there. Like I said, 20 feet per hour for 2-inch copper pipe hanging per guy. So 1 man hour equals 20 linear feet of 2-inch pipe. Like I said, a lot of the software has those kind of productivity measures in it, but where do they come from? Is that the country in general? Is that in our market? I'll tell you specifically, Chicago, working in Chicago and working in Louisiana or Seattle, there is a much different pace of work in a lot of areas where, work that would, get done much faster in Chicago might take, 30% longer in Louisiana, because they have a different work pace. They have a different productivity measurement. And one thing that when you're doing an estimate, you'll put in your line items, so your 1,400 pounds of duct work and 42 hangers and this much or that much, and it'll pop up a man-hour estimate. The kicker there is they ask you to put in your own multiplier. So, okay, well, based on your company and your location, you should put on a multiplier. Well, maybe I'll put in 1.2 because we're faster, or we're get more done, and we have better equipment. We have higher grade of engineer that did really good drawings, those kind of things. So that's where you end up with the factor adjustments. There's some examples here. They're fairly straightforward. 3 bricklayers, 2 helpers. That's a 5-person crew. Laid 1,200 bricks in 6 hours. What's the daily output? That's, they're usually fairly simple multiplication division kind of problems where they break it down into some measure of time over some unit of quantifiable measurement. So here it's, what's our productivity? Well, for that crew, 25 man hours is a million bricks, or that could be broken down in man hours. It could be, maybe it's 3.1 days per million brick, depends on, and those would be crew days, not single person days. Here they're decreasing by 20%, increase by 20%. That's when they're putting on their productivity factor. The other thing you have to worry about in a crew is, and it's not too pronounced in labor and union too much, you usually have to come up with kind of some blended rate, because your apprentices get paid a much different number than your superintendent. So each man day is not equal in those kind of situations. You usually look for some middle ground between, that's an average for your crew, where you actually take in, 1 apprentice, 3 journeymen, and a helper or a driver, something like that. I talked a little bit about fringe benefits, and some of them aren't fringe benefits necessarily. It's just a cost the employer has. Workers' compensation insurance, that's a big one. That's quite expensive. It's used in case, obviously if a worker gets hurt and can't work, and that's what the workers' comp insurance is for. Again, it's one of the biggest expenses when you have labor. Social Security tax, that's I think 7.5% paid by the employer. Unemployment tax, that adjusts based on how many times or who you laid off, and so that's why some places don't want to, would rather someone quit than be laid off, because their uninsurance tax rate can go up. And then any other taxes, when there's lots of FICA, all those other kind of taxes, and then employer provided benefits. Your employer might provide PPE for you to wear on site. They might have vehicle, all that kind of stuff. Or also those labor wage add-ons. That's how you get from the $51 that my sheet metal guy gets paid. Where do you get up? How do you get to $100 an hour, Pat? You go from 51 pretty close to 100 with all the fringe benefits, and there are some fringe benefits and that are not shown here in terms of retirement, and those kind of retirement is probably one of the biggest ones. They could have a 401k, they could be union managed savings, all kinds of other costs. Equipment. One thing I will say about equipment, you think I'd go out and buy an excavator, I can write the whole cost of that excavator off. I'm using it for business. Why wouldn't I write it off? Capital equipment, you often have to depreciate over time, where you're not saying, they're kind of treating it like a consumable in that case, where, okay, you bought your excavator and you wrote off $140,000 all at once. Well, that's not how that thing's used, and it's not how it should be depreciated. You can depreciate it, 20% per year for 5 years, or 50% the first year, and 10% each additional year, something like that. depreciation just means, you know, I buy it, it's worth $140,000. Each year I have it, it loses a little more and more value. Maintenance, investment, that's, you know, often there's a lot of contractors that, you know, an excavator costs a lot of money. A dump truck costs a lot of money. Oftentimes they won't buy it in one, you know, lump sum. They will, you know, put it out and they'll get a loan and pay for it via, you know, you're paying the loan by using it. Say you own a truck and you get a loan for that truck because it's you know, $120,000 for that semi rig, and that means you'll have to pay back that money and you'll have to pay interest on top of that money. So, you know, the monthly nut you'll hear it thrown out there where, well, the monthly nut on that truck, you know, I got to make $2,800 a month just to pay for the premium, or not the premium, the what's the word I'm looking for installment, like a mortgage, whatever. The payment plus the interest, principal, that's what I was looking for, plus the interest on a piece of equipment, taxes, operating expenses, you know, plates, tires, all that kind of stuff. That's always something to be considered when you're talking about equipment, is whether to rent or to buy it. I think I mentioned a little bit about, you know, depending on the equipment, trying to keep it, if you can't keep it busy and you only use it, you know, 4 days a month, it might make sense to rent it those 4 days than to buy it and let it sit. So the resource allocation, you know, leveling the resources, I talked a little bit about that, keeping the workflow kind of constant. Procurement, your procurement can help you identify, you know, your cash flow, and when, you know, predict cash flow and find out when you're going to need to, you know, dip into a line of credit the company has or something like that. And when you can make other purchases. Yeah, we should put off buying that Bobcat until March, because we'll have more cash flow coming in based on that project or something like that. There's another example of basically finding the amount of resources and the rates at which they're installed, their productivity rates. These are all fairly common, you know, problems where you're, you know, the cost of that bricklaying activity costs $17,820. And then you're trying to break it up by how much work did you do for that $17,820, and how many man hours? 1,900 man hours. Blocks, sorry, 1,900 blocks. Man hours. Yeah. Cost per day, how many? Okay. How much each component of the cost, how much it can do. And just to wrap this up, all that leveling, the resource leveling, identifying equipment costs, labor costs, all that information, that also, and I think somebody asked a question about it a little earlier in class about, you know, do we need to put all that information in a schedule? It depends on what that schedule is for. The point is, it's always useful information. Cash flow, you know, what you can't identify your cash flow until you identify the schedule. So, you know, when you pay out, you might have a $5 million project, and, you know, that middle month when I have to, you know, take receipt of that big transformer, I'm going to have $1.5 million out, you know, in material that month. Or, you know, this is our shutdown week, we're going to have 5 times the amount of labor costs that week. That's the point. We talk about schedule, we just think time and, you know, what what the sequence is and what the duration is, there's also a component on cost and where you're able to, you know, predict cash flow, predict expenditures. That all can be put into the schedule as well, and that's, you know, vital information, you know, when it's terms of asking for payment from the owner or whoever you're working for. You know, we're going to need 20% down payment because as soon as we start, we have to put so much down payment in machines. Any other? So there's the resource stuff. You know, I didn't consider 6 too hard of a chapter, too theoretical. I actually thought it was pretty good in terms of clear explanations. Anybody have any questions on what we went through or what I talked about?
No.
No. Okay. So I'll get out that explanation on the contiguous thing. I'll have that out for tomorrow. Like I said, the homeworks for 6, 7, and 8, those won't be required to be turned in. Again, I would suggest you do look at them, but I don't want to overload people. And so on Monday, I think the scopes, I think I'd have to check the date. Maybe I'll double check the date, but we want to get working on the scopes for our project number 1. If anybody has questions on project 1, you know, I'm happy to assist. Shoot me an email, shoot me a text. I'm happy to assist with, if you want help kind of determining line items for your project or, you know, what kind of project you're doing, what that'll entail. That's what I'm here for. If I can provide any help, I will do my best to do it. So other than that, that's all I got. I appreciate everybody getting on here, and I will send you your quizzes back as soon as I get them all input and everybody has them in. I will get them all back to you. Should be within a day or two. So your grades are up on the grades in Blackboard.
Thank you, Pat.
All right, everybody. Thank you very much for your attention, and I will talk to you on Monday.
See you. Thanks.
Bye.
Thank you.
Thanks. Good night.
Good night.